On this site, large diameter board piles were constructed. On the surface, they all look perfect. But are they? Chum, compatible with ASTM standard D6760, looks for the subsurface imperfections through the access tubes installed. Depth meter pulleys are placed on top of the water-filled tubes. Ultrasonic dual-function transceivers are lowered into the tubes. And lowered together all the way to the bottom, which may be 100 meters below ground level. When the sensors are level, the computer connected to the chum gives the order pull. While both cables are pulled together at a speed as fast as 2 meters per second, the location of the sensors is shown on the screen in real time. Ultrasonic pulses are continuously sent from the emitter to the receiver, and anomalies, such as increased arrival time or lower energy, are immediately displayed. Chum automatically adjusts signal gain for optimal signal quality under variable conditions. Chum also supports 2D and 3D tomography. Both sensors exit the access tube together, and the ultrasonic profile is already on the screen. First arrival time, relative energy, wave speed, and the waterfall presentation. Other profiles are logged the same way. The data is analyzed by the engineer who checks for any inconsistencies, adds his comments, and prints the report. This, in short, is the chum, our cross-hole ultrasonic monitor. BIT, Borehole Inclination Tester. Test an inclination of boreholes using to auger bucket as centralizer. The borehole is stable, but is it vertical? This is the BIT, Borehole Inclination Tester. Start by passing the cable around the wireless depth meter. Then, mount the BIT probe on the bucket and set it to 0 at ground level. After stabilization, lower the bucket to the first measurement stop. The software takes a measurement automatically at each stop. Raise the bucket back to surface, while stopping at the same stops on the way up. Finalize the test to get the overall deviation picture. Top view representation of the whole deviation. Side view representation of the whole deviation. The square pier is surrounded by diaphragm walls. The wall elements were cast with access tubes for cross-hole ultrasonic testing. The walls are 30 meters deep. Are they vertical? The bit sensor and centralizer are lowered into one of the tubes. The bit is lowered to the first stop at 5 meters. With the stop sign switched off, the bit is lowered to the next stop. The procedure is repeated all the way to the bottom. The bit is now raised, stopping at the same stations. The bit is now at the surface for final reading. The top view is now seen on the screen. The side view is plotted on the screen in the desired direction. The deviation of board piles is measured the same way. The bit can also test simple low-cost tubes for geophysical testing. Thank you for watching.
Upon opening the program, it will ask for a data file. In this example, open the raw data file example 1. Type in, for example, in this case, just a random blow count here, just for illustration purposes. The pink will be the set. Hit auto offset will adjust the green displacement line to match the pink. Let's have another example, different blow count. Hit auto offset, it will adjust the green displacement line to match with the pink line. Another example, another blow count. In here, we don't use auto offset anymore. We place the mouse on A3 and just spin the mouse to change the A3 number. And then you can see that the green line move because A3 changed. The best would be when the green line is about flat, where V is close to 0. back to this actual blow count, 66 blow per foot. Hit auto offset to find the best adjustment, and then hit OK to accept the adjustment. For non-uniform pile, you need to add pile segment. However, this is uniform, so you can skip and go right ahead to type in the free length. Program will give you prelim results right away. Blow count is not quite matching yet, but we worry about that later because this is still rough. Slide the slider here to change the scale of the graph. And you can see that there are 3 splices here, and we need to model those splices in additional node parameter table. This is welded plate on the steel pile, so the impedance is higher, and we implement the higher impedance at each splice in this additional node parameter table. The results will be updated immediately without you having to do any analysis. At this point, you can hit F4 on the keyboard, and these mini auto results improve a lot, but still